In example 3, we're being asked to find the area between this parabola given by our function rule over here and the x-axis bounded from x equals 1 to x equals 4. And this is an irregular area. There isn't a formula from geometry we can use to calculate this precisely. In class, we estimated the area by using rectangles. Eventually, we used a lot of rectangles and got a really good estimate, but we can use calculus to get the exact area. And that calculus involves taking the definite integral of our function from x equals 1 to x equals 4. So I have my bookmarks there, my integral notation and that dx. I have my function trapped between those bookmarks. I'm being shown my lower limit of integration and my upper limit of integration. Let's go ahead and put our function between those bookends. Okay. And since our function has 3 terms, we're actually going to take the integral of each term individually. Now, each of these terms happens to fit the power rule. Different terms can follow different integral rules. I do need to do a little rewriting to make the terms fit the power rule exactly. In this first term, there's an understood -1 in front of the x squared. So I'll pull that out to the front. And I'll end up with -1 times the integral from 1 to 4 of x squared dx. So now I'm set up for power rule. I just have to remember to multiply that -1. Okay, so x squared, when I integrate, I'm going to get x to the 2 plus 1 exponent over 2 plus 1. And instead of writing plus c, I'm just going to use my limits of integration from 1 to 4. Okay. Then I'm going to add, well, again, I need to pull out that constant 4 and multiply it in front of my integral to get this to fit my power rule, which it does now. I have x to the first. So I'm going to end up with 4 times x to the 1 plus 1 exponent over 1 plus 1 from x equals 1 to x equals 4. Plus, well, to make this last term fit the power rule, I need to recognize I technically have an x to the 0 power there. Pull out that 1 in front of my integral there. Okay, or you could just say it's an understood 1, so it wasn't really there because multiplying by a factor of 1 doesn't change our product. Okay, so now we're set up to do our power rule. So I'm going to end up with the integral, with x raised to the 0 plus 1 exponent over 0 plus 1. And we'll integrate from x equals 1 to x equals 4. Okay, now let's clean this up. Okay, so I just did the addition in my exponents and in my denominators. Ooh, I can clean this up a little bit more because I end up having a 4 over 2, so that'd just simplify to a 2x squared for that middle term. And then we have in our last term an x to the first over 1. Well, I don't need that understood exponent of 1 written, and dividing by x by 1 would just give me x. So my last term just ends up being an x. So now we'll just evaluate with our limits of integration. Okay, so I plugged in x equals 4 and x equals 1 into our first term, being very careful about the negative because then we subtract those terms. So we'll end up with a double negative later. So watch out for that. And then in our second term, I evaluated a 4 and a 1 and subtracted the results. And in our last term, I evaluated a 4 and a 1. And oops, I need to subtract those results, not add. There we go. And that gives us -21 plus 30 plus 3. And that will simplify to 12. So the exact area under that curve was 12. And that value fits in with our estimations we got on page 2, where we estimated that the area was between 10 and 13. Okay, and you can also get this exact area using technology, using either Desmos or a graphing calculator. Those steps are written out on the following page and we'll demonstrate it in class. Now, you'll need to know how to do this by hand on the test, so definitely practice it by hand, but you also want to be very comfortable using technology to get these exact answers and to check your work. So practice by hand and follow up with technology.